Okay. So this is question 2. So it's saying that consider this this is space or collection of vectors such that x, y, z is coming from R3 and alpha x plus beta y plus z is equals to gamma. And alpha, beta and gamma also I think are coming from, there should be gamma as well here, are coming from R. Okay. So it's asking for which of the following choices the set V becomes a two-dimensional subspace of R3 over R. Okay. Let's do this. Okay. So it's asking us for which values of this it will become a two-dimensional subspace. Okay. So what are the conditions for a subspace to be? Can you give me some conditions? It should follow additive property, right? I'll write the trivial ones. You'll give me the other ones. Multiplicative, right? And closure property as well. And also one thing is important is that zero vector should be there, right? Correct. So we have these properties, right? So one of these we can immediately rule out based on the zero vector. Can you tell me which of the ones we can rule out based on the zero vector, and which of them will not have 0, 0 as a solution or 0, 0, 0 as a solution? So I know Rohan, you have already done it. So Varshita, can you give me one of these where we can rule out immediately some option where, it's not passing through origin? Let me do this here. So, okay. These are my equations, right? So let's see the example B, right? Alpha x plus beta y plus z is equals to gamma, right? And they're given us alpha is equals to 0, beta is equals to 1, and gamma is equals to 1, right? If I put these values, I'll have y plus z is equals to 1. So this is an equation of what? A line, a plane, or what? Also, x is a free variable, right? Are you able to grasp that? Why I'm calling x as free? Because no matter what value I put for x, it'll always satisfy the equation, right? So x kind of free. So given that, can you tell me what is y plus z is equals to 1? And also you'll have 0 of x. X is free basically. Can you give me what this is an equation of?
Plane.
Plane, right? And what kind of a plane?
2D plane.
Plane is always 2D. Is it passing through origin?
No, ma'am, it has some interceptor.
It has an intercept, right? So can we discard this immediately?
Yes, ma'am.
Okay, so I discarded this immediately because this does not have 0, 0. Correct? Fine. Now let's look at the other examples. So I have A, which is like alpha is equals to 0, beta is equals to 1, and gamma is equals to 0, right? So what I have is um I have just one equation, right? This is 0 plus beta, beta 1, so y plus z is equals to 0. I have just one equation. And I have how many variables? And my x is again free, right? And y I can write as minus z. So I can create a basis for this like this. I'll set this to be, okay, let me write it like this, x, y, and minus y, right? And can I write it like this? 1, 0, 0 plus y, 0, 1, minus 1? Yes, no? Right? Uh, are they linearly independent? Can you look at them and tell that they are linearly independent? You can, right? Because see, for constructing, for there is no way I can get a 1 here, right? I have to add this vector, right? So they're linearly independent. So I have two vectors in this equation. What will they span? They will span a, they will span a line. Two vectors will span, linear combination of two linearly independent vectors will span what?
Plane.
Plane, right? Be quick, right? So this option is correct. This is what is being asked, that the set of V becomes two-dimensional subspace. So it's a two-dimensional subspace, I can say. Yes, no? Okay. So this is correct, right? So this is correct. Fine. Now let's do other two. Um, Fine. So we have eliminated D. A is correct. Now let's do the C part. Now you have to quickly do this because this is the same thing. Gamma is equals to 0. What is the equation I'm going to get? X plus beta is 0. So x plus z is equals to 0. What is the variable I'm going to get? So basically x is equals to minus z. So the thing that I'm going to get is y minus z, right? And I can write them as z minus 1, 0, 1 plus y 0, 1, 0, right? Two independent vectors again. So two-dimensional subspace. Yes, no? Yes or no? Yes, right? Correct. So this is all, this option is also correct. Let's quickly do the last option, which is D. Alpha is equals to 1, beta is equals to 1, and gamma is equals to 0, right? So this is x plus y plus z is equals to 0, right? So x plus y plus z is equals to 0. This is an equation of a plane. We already know that, but let me do this as this, right? It's equals to minus z. How will I create basis for that? I will write x, y, and z, right? Which is equals to x, y, x minus y, which is equals to x 1, 0, minus 1 plus y of 1, 0, 1, minus 1. Can you verify these are linearly independent? Fine. So this option is also correct, right? So only B option was incorrect. A, C, and D are correct.